one is empirical probability, and another one is a theoretical probability. So empirical, which is based on the experiment, the empirical probability is an estimate. Empirical probability is an estimate of the theoretical probability. It is just estimate, and if we try more and more, it will be a good estimate. And then, for the theoretical probability, why we use a theoretical probability? Because if we have a theoretical probability, then we may predict the future outcome. So we know that when you toss a coin, then we know that the probability of getting half is 1/2, right? So, but if you toss a coin, actually, you may not get a 1/2. You may get like this. You may get a 0 or 0, and then you, after getting a certain number, it is closer to 1/2. So it is a prediction. It predicts. It helps to predict the proportion or like a possible outcome by using the theoretical probability. That is a way to interpret the empirical and the theoretical probability. Anyway, let's do the following example. And this is a really important example in the biology. If you're in the biology, I think you heard about this. The name Mendel. Have you heard about the Mendel?
No.
Yep. I think he is one of the most famous in the, well, I don't know, like the biology, because, usually like the genetic, like the gene expression, most of them start from this, like the experiment. So he found that the flower color in certain pea plant obey the following. Pure red crossed with pure white produced red. So we have a red, pure red, and pure white. And suddenly they get a red. Why this is that? Why not the white, right? You may ask that. Why not white? So the red is the dominant, so use R, the upper letter, and the white is recessive, which is used like a smaller letter, small case, small r, and the pure red parents carried only the genes for the red, this capital R, and the pure white parent carried only the gene for the white, this small r. And the offspring would receive one gene from each parent. It is the same as like your parents, after your parents married, you got either boy or girl, right? Either like XX or XY, like the gene. That's the same thing as this. So what happened is for the first parent, there are two parents. The first parent may have both are pure red. And then the second parent has just white, so second parent. White, but carry the small letter r. And when they combine, it is r, small r, capital R, small r, capital R, small r, capital R, and the small r. So all of them are red, right? Now, all of them are red, but it doesn't mean that they are pure red, because they have the white in it, right? But on the second generation, this is like the first generation. On the second generation, it is different. All of them has capital upper letter and the lower letter case. So if we continue one more time, the gene can be either from the upper letter or from the small letter, R. And R and small letter Then this is R, R small r, and capital R, and the small r and the small r. Now we have the white. And we have a pure red, and the pure white. We have these possible ways. So white is somewhat like the recessive word. It is not a dominant. And if you continue this further and further, there are like the really less white plant in this case. So what is the probability of getting white as an offspring? For the first generation, there is no white. So the probability of getting white is 0. But for the second generation, there is 1, which is 1/4. That's the probability of getting white. Does it make sense? Now we go further. Now we want to determine the probability that a third generation of spring, well, which is like the third one, will exhibit each flower color based the probabilities on the sample space of equally likely outcomes. The sample space S is RR, RS, small r and upper r, and the lowercase rr. And the red, the probability of getting red is, it can be a pure red, which is this, or the red is, it can be RR, R and small r, and small r and the upper r. That is a 3 out of 4 is the probability of getting red. And the probability of getting white is a white is just one case, which is a small r and a small r, which is 1/4. And that is a probability. Any question about this? It follows the same thing as like the human's gene, XY and XX, etc. Right? It follows the same thing. Or the blood type also follows some kind of a rule, this kind of a rules. Okay, the odd. I think you heard about the odd, usually in the lottery, right? So odd compare the number of favorable outcome to the number of unfavorable outcome. So we count the both. So if all the outcomes in a sample space are equally likely, we have A. So A of them are favorable outcome or the favorable event, and then remaining B outcomes are unfavorable to the event E. Then the odd in favor of E are A to B. So the odd in favor of the event E is A to B. So we usually use this, A to B. And the odd against the event E is B to A, which is unfavorable. The outcome is the first, and then the favorable is later. So B to A is against the event E. So let's think about the following. So Teresa has been promised one of 6 jobs. And 3 of which, so 3 of 6 will be intern position at the state capital. And if she has equal chances of all 6 jobs, so there is a equal probability. And we're going to find the odds that she will get one of intern position. Then what is a favorable outcome? So there are the favorable event is intern position. So event E is, how many are there?
6.
There are 6 jobs, but the 3 of them are intern, right? So this event E is a 3 position. The sample space S is a 6 jobs. So 6, 3 intern, and unfavorably is also 3 position. So 3, 4 favorable, and 3 are not favorable. So the odd in favor of intern positions are 3 to 3. Because we have a 3 favorable intern position and 3 are not favorable, not favorable jobs. So 3 to 3, which is basically the 50-50 chance. Or even odd. That's another meaning of 50-50 or the even odd. I think you heard about the 50-50, right? That means that your favorable outcome is the same as your unfavorable outcome. When they are the same number, that is like a 50-50 chance. Okay. Any question?
So that colon there between the 2 of them, that's the.
Mm-hmm. That's usually colon. Yeah.
What do you call it?
3 to 3.
So 2 is that symbol means
Yeah,
2.
2. Well, when there is like a soccer game or like a football game, you usually have a number versus another number. That's the 2, or that column, right? Isn't it? Yep, that's the same here. There's no difference. Now, Bob has purchased 12 tickets for an office raffle. So there is like the raffle ticket. I think you play the raffle ticket a lot, right? So there are 12 tickets for the raffle. There is a winning. The winner receives an iPad. We don't care. So there are 104 tickets altogether, but only the 12 of them are like a winning ticket. And each has an equal chance of winning, because otherwise you have to complain.
Yeah.
What are the odds? We're going to compute the odds against Bob's winning the iPad. This is against. So let's compute that. Well, do you know the answer? What is against?
92, 104.
92. What did you say?
Yeah, 92 is 104.
Yeah, 92 to
104.
104. Well, let's see why this is 104. You are computing the different one. So
Yeah, I'm going with the against. The odds have to be 12 minus, 104 minus 12. The
so
leftover.
Bob has a 12 chances to win. And this is actually favorable. And then, what is unfavorable? The total is 1 of 4 tickets. And he only has 12 tickets. Right? So the unfavorable total is 1 of 4 minus 12, which is 92 chances to lose, which is, this is unfavorable. Event or unfavorable outcome. And this is against. Against winning. R. For the against, we do the unfavorable first. So 92 to 12, which is 92 to 12.
I thought it would be out of the total 104.
No, odd for the favor. That is for the probability. So do not confuse with the probability versus the odd. They are slightly different. That is a probability because 1 of 4 is a total outcome, right? And we'll discuss that in the next slide.
So the words odds and the words probabilities don't equal?
They are not equal.
So if I give you the odds of winning and I give you the probability of winning, they could be different?
They are different.
Weird.
Yep, they are different.
So in that problem, what's B and what's A? If you're looking at the favorable and unfavorable.
The favorable, because it said that the favorable, obviously winning is a favorable, right? So the odd is favorable is 12 chances of winning. That's a favorable because you want to get that. And unfavorable is not just a total number. It is to subtract the favorable outcome out of the total. It is like you play with the opponent, like the soccer game. The total number is fixed, which is 104 point is a total. Now you got a 12 point, and then the opponent will get a 92 point, right? Isn't it?
Yeah.
So you're favorable of winning, the odd of winning, your team is 12 to 92, but the opposite, the odd against winning, which is basically losing, is 92 to 12.
If you turn those numbers around, 12 to 92, you couldn't do that? They're not same.
That is a different number. So
yeah.
if you fit the favorable first, that is odd in favor of winning. If you fit the unfavorable first, that is odd against the favorable.
Say that one more time.
Okay.
Once is not enough.
So the odd against, when you say the against means you get an opposite number, opposite thing, right? That's the against. So you have to fit the unfavorable first. But when you say that odd in favor of winning, means you wanna put the favor. Odd, that is, I have to put the odd in favor. That is a favor. means you fit the favor first, which is a 12 to 92. So that is a 12 to 92. That's the number. And as he said, as you said, that the odd and the probability are very close to each other, but they are different. So you can see that here. Converting between the probability and the odd, so they are very close to each other and they are related with each other. So let the E be an event, and then if the probability of E is A over B, so A is your favorable event or the favorable outcome, but the B, when you say the probability, the bottom, this B is a total outcome. This B contains the favorable and unfavorable, the both of them, right? Because that is the total outcome. Then the odd in favor of E are A, because A is a favor, and then B minus A, this is unfavor. Yeah. Does it make sense?
Slowly.
Yeah. The odd in favor of E are A to B, which is A to B. That's the opposite. So, if the odd in favor of E is A to B, that implies this is a favor, and this is unfavor. But when you compute the probability, we also have to compute the total outcome. But the total is A plus B. Total is always favor plus unfavor. So the probability of E is A over A plus B. It is, I know, it is confusing. Sure, obviously, it is confusing. But there is a difference between the odd and the probability. There is a difference.
Where's the 2 sign and the odds when you have PE equals A over A equals B? No 2 sign, no double dot to show you where that goes or which relationship?
So when you say that the probability of E is A over B, that means odd in favor of E are A to B minus A. When you say that the odd in favor of E are, this is not in 2 directions. This is in 1 direction, this direction. The odd in favor of E are A to B, implies the probability of getting E is A over A plus B. So the odd, when you say the odd, we always compute the favor versus unfavor. Favor versus unfavor is odd. When you say that probability, we always say that the denominator is the total outcome. The total outcome contains a favor and then unfavor also. Any question? So let's compute the odd. So there is a 30% chance of rain tomorrow and give this information in terms of odd. So we have a probability of rain is 30%, which means a 30 over 100, which is a 3 over 10. That is a probability, right? Now we want to compute the odd in favor of rain.
Three, 7.
Then odd is a 3 to 7.
I got
So 3, yeah, you got it, finally. So 3 is a favor of rain, but the 7 is unfavor of rain. So 3 to 7. So he got it. So
one. Yeah.
I guess all of you know that, right? Any question? Okay. So let's move on to the next section, which is a section 11.2. Event involving not and or. The always the probability is between 1 and 0 and 1. The 0 is never appear, never occur. 1 is always occur, right? So the probability, the properties of probability, let the E be an event within the sample space S. That is, E is a subset of S. Well, you don't need to worry about this kind of wording. Then the following hold. So, the probability of E is the number of element in the set E over the number of element in the sample space S. That is a probability, but that probability is always between 0 and 1. And when there is no event occur, that is an impossible case. The probability is a 0. When the event occurs all the time, which is a probability of the sample space, and that is always 1, that is a certain. But most of the case, the probability is between a 0 and 1. So, for example, the impossible case is when it toss a dice, a fair dice from 1 to 6, and when it toss that, it lands on the 7. It never occur, right? It is impossible. So that is a probability of getting the 7 by after tossing a dice is the 0. And the probability of how about getting a number between 1 and 6? It always occurs from 1 and 6. So the probability of that event is 1, which is always occur or all the time certain. But either 0 or 1, they are boring, so we usually discuss the between a 0 and 1, not 0 and not 1 case. When a single fair dice is rolled, and we want to find the probability of each event, the number 2 is rolled. So the event E is 2, and the sample space S is 1, 2, 3, 4, 5, 6. So the probability of getting event E, or number 2, is 1 out of 6. A number other than 2 is rolled, which means the event E is except 2. 1, 3, 4, 5, 6. So the probability of event E is 5 out of 6. The number 7 is rolled. It never occurred. It is empty set. Or it never occurred. So the probability of E, well, the probability of E is 0. Or this is the same as the probability of the 2, and this is the same as the probability of other than 2. And this is a probability of 7. And then a number less than 7, the less than 7 is the event E is the same as the sample space says. So probability of event E is always 1. So which is a probability of less than 7. That's the probability. I think those are straightforward, right? So let's move on. The event involving not. So probability of a complement is that it is the name is a complement or not E. The probability that the event E will not occur is equal to 1 minus the probability that it will occur. The total probability or the whole thing is always 1. So from the 1, if we subtract the favorable outcome E, then we get the opposite. So that means the probability of not E is the 1, because this is a certain. From the certain point, we subtract the probability of E, then this is not E case. Let's say that, let's assume that on your final exam, your final grade is for the, I don't know, who is the best for the mic? Can I? Yeah, so for the mic, let's say that the probability of the mic getting the A is, what do you like? 40%?
No, come on,
Let's
hell
say
yeah.
40%.
I might surprise you. Maybe get an A. It'd be like,
So the probability of getting A for the mic getting A is 40%. Then what is the not getting A? 60%. Does it make sense? That is what this is. The probability of not getting A is 1 minus the probability of getting A. So in a set notation, we use the following. You don't need to worry about this. This is just, if you go to like upper level, this is what they do. So this, for the whole set, this is a sample space set, and this is like event E, and all others are, all others, all of them, except E, is E complement. They use this symbol complement. Then the sample space S is E union. That is a union symbol, which is combined, or the combination of all of them, and E complement. So when you compute that, the probability of S is the probability of E union, E complement, which is the probability of E plus the probability of E complement. And the probability of the whole sample is always 1. Now what we want is, we want to get this. The probability of E complement, which is the same as not E. Then 1 minus the probability of E is the probability of E complement, which is that one. But I'm going to erase that because you don't need that.
good.
that makes life much more complicated. Any question?
So, can you just summarize that? If, you know what you just wrote. I mean, isn't it similar to the like if I say 1 to 1,000,000 as
Oh,
an odd?
we'll discuss an example then. It will
Yeah,
be
okay.
much more clear. So when a single card is drawn from a standard 52 card deck, which is this card, that is a 52 card, what is the probability that it will not be a king? So the probability of not a king is, well, we can count that, except this like a king. 1, 2, 3, 4. We have 4 kings, right? Except this 4 king, we can count all of them, which is 52 minus 4, which is a 48, right? We can count the 48, not king, and we can compute the probability of 48 over 52. It is possible. However, we can also compute the not king as 1 minus, the 1 is a whole space. So 1 minus the probability of a king. Then 1 minus the probability of a king is a 4 out of 52. So we got a 48 over 52. Which is the same as, if we do the cancellation, this is the same as 12 over 13.
I got that.
Okay.
That's
Now let's-
2 I got right there.
Yep, that's good. So let's do one more. So if the 5 fair coins, there are 5 of them, and this is a coin, are tossed. Now we want to find the probability of obtaining at least, this is somewhat like a tricky, at least 2. The at least 2 means it can be a 2 hat, it can be a 2 hat, or 3 hat, or, how to say that, the 2 hat, or 3 hat, and 4 hat, and 5 hat. It means it can be any of this, right? That means we have to count many possible things if you want to count in this way. But if we do the opposite way, the probability of at least 2 hat is the same as 1 minus the probability of at least 2 means it is a 2, 3, 4, 5. What is the opposite of 2, 3, 4, 5? Getting 2, 3, 4, 5 hat. What is the opposite?
Not.
We get a none, or we get a 1 half. So this is at most 1 half. If we subtract the probability of at most 1 half, then this is the same as the probability of at least 2 half. Does it make sense? This is like the probability of not E is 1 minus the probability of E. They are complement, right? And most 1 hat means 0 hat or 1 hat, and then at least 2 hat means 2, 3, 4, 5. Now we can count the case and most 1 hat. The and most 1 hat means we get a 0 hat or 1 hat, isn't it? Now how many total outcome? Number of total outcomes from 5 coins is when you toss one coin, how many outcome? How many possible outcomes? When you toss one, we got a 2. So we toss the one other coin, which is a 2. So 2 times 2 times a 2 times a 2 times a 2. That is the total number of outcomes, which is 2 to the 5, which is a 32, is the total number of outcomes. If I write down that, it can be like a T, 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 and T, 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 H, and then all the way through H, 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 H. That's the sample space. S. Now we don't want to count the 2, 3, 4, 5 hat. We want to count only 0 hat or 1 hat. Now 0 hat is, that means the T, 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 right? And 1 hat is T, 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 H. And then the combination of that, which is a T, 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 H, T, and etc., and H, T, T, sorry. Then we have H, T, 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 T. So how many possible ways for the 1 hat?
4,
4?
5.
5. We have 5 of them. Can you count the 5 here? The hat can be appear in any place, either the last one or either the first one. So there are 5 possible ways. Then this is 1 minus 5 out of 32, which is a 26 over 32. And that is a probability of getting at least 2 hats. Does it make sense?
Wait, how'd you go 532 to 2632?
So, sorry. Yeah, I made a mistake. So there is a 0 hat is 1, and 1 hat is a 5, right? So the total is 6 possible ways to get at most 1 hat, right? So 1 minus 6 over 32, which is 32 over 32 minus 6 is 26. So 26 over 32. Is it okay? Yeah. All right. That's all. Yeah, that's all for today.
Take the rest of the day off.